Dear student, today my topic is partial fraction. Before going to introduce partial fraction, let me go to the previous classes when we were in the school. So at that time we were given some questions, some algebraic fractions, maybe two or three. In between them we were having plus and minus sign, as we already know that whenever we have two or more than two algebraic fractions and in between them we have plus or minus sign, then the only process which we will have to adopt, that is LCM. And we take the LCM of denominator and solve the question. At the end we get a single result. The result might be consist of numerator and denominator, and maybe only numerator. There might be some cutting because of the result of cutting, crossing of factor of numerator and denominator. So at the end we will have only single numerator answers. So uh, in partial fraction, as I explained now, that in the previous grades we were given some partial parts of some questions, and we were trying to get the result of that partial fraction. But here the result is given. In partial fraction chapters, it means that you will have a result and you will have to split that complete result into two or more than two partial fractions. But before going to further speaking about the partial fraction, let me just say that the partial fraction is similar, which can help to solve more complicated fraction. For example, it is very useful to calculate, which is a branch of mathematics, that in the previous grades, for example, we were given some question like 2 divided by x minus 2 and plus 3 divided by x plus 1. Let me write it again. So here I can write 2 divided by x minus 2, then plus, and 3 divided by x plus 1. So in the lower grade such type of questions were given, because we already know that this is one algebraic fraction and this one is the second algebraic fraction. So these type of algebraic fractions were given, and in between them the number of algebraic expression were not limited. They may be two, maybe three, maybe four, but in between them there was a symbol plus or minus, because whenever we have plus and minus, so the only possibility of the process of mathematics which we have will have to adopt, that is only LCM, and a LCM of denominator we have to find, these two or denominator. So at the end, because we know the process that how to solve this type of question, so at the end we were having the result of these two, 5x minus 1, 5x minus 1 divided by x square minus x minus 2, x square minus x minus 2. So this was the complete result of solving these two algebraic fractions. But now this complete result has been given, and we have been asked the question that split this complete result into two or more than two algebraic fraction. Now the number of algebraic fraction we don't know. The number of algebraic fraction only depends on the denominator, because we have four possibilities while solving and splitting one complete result of algebraic fraction into partial fractions. So the only I'm going to explain it again. I'm going to repeat it, that the number of algebraic fraction, that how, for example, we can say that how many algebraic expression, algebraic partial fraction we will have while splitting the complete result. So it depends, the number of partial fraction depends upon the denominator of the algebraic fraction which is given to us. Second thing I'm going to explain, that before solving, as I explained the procedure, that in the lower classes these two were given, so we were having to find these complete result. Now this complete result will be given and we will have to find the splitting form. And one thing more I want to explain, that is, whenever these two partial fractions were given, at that moment there was no need to say or to think whether these algebraic fractions were proper or improper, because we already know the proper and improper fraction. Let me just explain for short time, that proper algebraic fraction. Now I am going to proper fraction in numbers, in a real number, not in a variable. So just imagine, let me write something, 2 divided by 3. When we were in the lower classes, at that time we were saying that if the numerator value of real number is less than the denominator, then we call it proper fraction, because the numerator is less and denominator is greater. 2 is greater than 3 is greater than 2. So numerator is 1 divided by 4 or 5. Since we know that numerator is less and denominator is high, so this type of fraction is called proper fraction. But that were only in real numbers. What is improper fraction? The improper fraction, we can say there are two possibilities. In proper, only one possibility, that the upper should be lower than the upper should be lower number, and the lower should be high number. So this was the proper fraction. The numerator should be less than denominator. That is called proper fraction. Against of it, if the numerator is high and the denominator is low, for example 3 divided by 2, these two, this fraction is called improper fraction, because numerator is bigger than denominator. Similarly, we can also say that 5 divided by 2, 5 is greater than 2. It means since numerator is greater than denominator, so the answer is improper fraction. Another thing, while solving, while finding the improper fraction, one thing, numerator should be high, should be large than the denominator. Now come to the another point. When both the numerator and denominator are same, then we can also call it improper fraction. Just imagine 3 divided by 3, because both are same numbers, so they are called improper fraction. Now these were the proper and improper in only in real numbers. But let's come to the variable. Now, for example, I'm writing two variable. One is in numerator and the second one is in denominator. Then on the basis of what we will decide that whether it is proper fraction or improper fraction. So on the basis of the power of variable, just imagine x, let me write x plus 2 divided by 2x square minus 7. Now this is called proper fraction. What is the main thing on behalf of which we can say that it is a proper fraction? Because the above is also a polynomial and the lower denominator is also a polynomial. The above one is called p of x, yani polynomial with variable x, whereas in denominator we call it q of x. It means q with variable x. Polynomial p of x and the second polynomial, that is q of x. Why it is called a proper fraction? Because the degree of polynomial in the numerator is 1, whereas the degree of polynomial in the denominator is 2. because you already know the degree. Degree is the highest power of variable. So x power 1, here x power 2. Since the degree of the upper polynomial is lower than the degree of lower polynomial, therefore we call it proper fraction. Same, just like with the comparison of the numbers, we can decide whether it is proper fraction or improper fraction. Now we can decide what should be improper algebraic fraction. Let me write. For example, 2x cube divided by x square plus 1. Now this one is improper fraction because the degree of polynomial in the numerator is 3, whereas the degree of polynomial in denominator is 2, and the above degree, the upper numerator degree is greater than the denominator. So this type of algebraic fraction is called improper fraction. Similarly, as in number, when the number in the numerator and denominator were same, they were also called improper fraction. Similarly, we can also write 2x square plus 3x minus 9 divided by 2x square plus 4x. So now this one is also improper fraction because the degree of polynomial in the numerator and the degree of polynomial in the denominator both are same. So this type of algebraic fractions are also called improper fraction. Now come to the point. So the main point is here to solve given algebraic expression. I can say instead of solve, if I say split, it will be quite convenient word. So to split a given algebraic expression, algebraic fraction, not algebraic expression, because algebraic expression is the only one which is in denominator or the only one which is in denominator. But when combine both of them, then they are called algebraic fraction, not algebraic not algebraic expression. It will convert, the name will be algebraic fraction because one is in numerator and the second one is in denominator. Then they both are called combinedly the algebraic fraction. Now come to another point. Whenever we have to solve, as I explained earlier, that the number of partial fractions is based on the denominator of the algebraic fraction which is given to us in order to split. Because whenever algebraic fraction is given, we have to split, we have to make a reverse process of the previous grades, because in the lower grade we were solving two or more than two algebraic expression and were combining them into a single result. But now here the reverse process, single result is given and we have to split the combining result into partial fraction. And the number of partial fraction depends on the I can say the polynomial given in the denominator. So now there are four possibilities. There are four possibilities on behalf of which we have to split every algebraic fraction into its partial fraction. The first possibility, let me write it. So the first possibility is, I can say that the one when q of x, and we already know that q of x is the denominator of algebraic fraction, because I already explained that we have to focus on the denominator. First we will have to check whether proper improper. If it is proper, it is has a separate method procedure. When it is improper, then it has some other method. Later I'll explain that when we have proper fraction what should we do, and whenever we have improper fraction then what should we do. But here I am going to explain that how many possibility we will have in this chapter regarding solving a combined result of algebraic fraction into partial fraction. So the first case, that is when qx consists of non-repeated non-repeated linear factor. This was the first case, because whenever we are given a question, a combined result, and we have to split, the first thing we will have to check improper or proper. The second thing which we will have to focus on, that is, we will check the denominator of the given algebraic fraction. I mean to see the qx, because the above one is called p of x. So the qx consists of non-repeated linear factor. This is the case number one. What is the second case? When qx consists of repeated linear factor. The one non-repeated linear factor, the second repeated linear factor. And the third case, when qx consists of non-repeated quadratic factor. Because we already know here there is one confusion, and let me finish this confusion in the mind of the student, that in the denominator we will have a quadratic factor, and that quadratic factor, whenever factorize it, so it will have two factors, because we already know that whenever we will have quadratic equation, so that quadratic equation we can solve by three methods: by completing square, by factorization, by quadratic formula. So they will be split it into two factor. So what should we decide here at that moment? Should we keep that case in the case number 3, or this belong to the case number 1? Now the question arises: in the denominator you will have non-repeated quadratic factor, that is true, but that quadratic factor will not be factorizable. You are not able to factorize, because whenever sometime we have such type of quadratic factor which are not factorizable, I mean to say you cannot factorize them. That is called quadratic factor. And if we have a quadratic equation in denominator, so first of all we will have to think that this quadratic equation might be factorizable. It will split into two factors. So in case of factorization, as a result we will have two factor. So it means that the case does not belong to, that question does not belong to case number 3. This question belong to case number 1, because in the denominator there might be two possibility, and that two possibility we can say that these two factor may be repeated, may be non-repeated, may be equal, may be different. So in this confusion, then we will have to decide whether the question belong to case number 3. I mean to say, when qx consists of non-repeated quadratic factor, or the question belong to case number 1, that the denominator, I mean qx, consists of non-repeated linear factor. I am telling you this reason, that at the case number, in the case number 3, there will be quadratic factor, non-factorizable quadratic factor. So you can decide that this question belong to case number 3, because in the denominator the polynomial of degree 2 is given, but that is not factorizable. We cannot convert them into factors, and we cannot say that since these quadratic factor is not factorizable, and in turn it cannot be converted into two factors, so therefore it does not belong to case number 1, it belongs to case number 3, because that quadratic factor is not a factorizable. So let me repeat it again. Case number 1, when qx consists of non-repeated linear factor. Case number 2, when qx consists of repeated linear factor. And case number 3, when qx consists of non-repeated quadratic factor. Similarly, the last case, 4 number, when qx consists of repeated quadratic factor. Non-repeated linear factor, repeated linear factor, non-repeated quadratic factor, and repeated quadratic factor. These four cases we will have to focus on while solving, while splitting a given combined result into partial fraction, because on the basis of these four cases we can split the given combined result into partial fraction and solve and follow the procedure how to solve a complete result, how to solve a complete questions. So this was the a little bit summary about the partial fraction chapter. Let me just summarize that partial fraction, I will say that in the previous lower grades, I mean to say in the 6th 7th grades, we were given some numbers, some question which were consist of two or more than two partial fraction, whether in numbers, real numbers, or in algebraic form. And we were solving them. In between them there was a two operation, might be plus or might be both a plus or minus. So at that moment whenever we were solving them, so the only process we were adopting that was LCM, and by complete process we were solving and we were finding the complete result. Now the complete result is given and we have to make a reverse process in order to split the combined result into partial fraction. But before going to solve, we will it's important to know about the proper and improper fraction. So let me consider the real number. Whenever the numerator is less than the denominator, that is called proper fraction. And if the numerator is greater or equal to the denominator, greater than denominator or equal both of them, numerator and denominator, that is called improper fraction. Same in the case in algebraic fraction as well, because in algebraic fraction the degree of polynomial in the numerator is less than the degree of denominator of the polynomial, that is called proper algebraic fraction. But if the degree of polynomial in the numerator is higher than the denominator or both of them are equal, that is called improper fraction. And now I'm going to explain just about four cases that whenever we have to solve such type of question into partial fraction, we have to focus on the denominator of the algebraic fraction which is given. The case number one, the denominator consists of non-repeated linear factor. Case number two, when qx, I mean denominator, consists of repeated linear factor. Case number three, when denominator, I mean q of x, consists of non-repeated quadratic factor. And case number four, when denominator, I mean qx, consists of repeated quadratic factor. On behalf of these four cases, we will solve every problem by its own method. Proper has its own method and improper fraction has its own method. So this was a little bit summary about this whole chapter, because in this complete chapter we will have questions which will involve the first case, second, third and fourth cases. So this complete chapter I just summarized. Because of these four cases we can solve this complete chapter. So this was the end of this topic. Thank you so much for watching this video.